Hi, this is Jeff with Circle Prosco's Solution Squad, and today I'm bringing you the fourth video in a short series that we're running on myths and misconceptions that exist about zirconium pretreatment technology. Today's myth is that zirconium pretreatment coatings are thin and that thicker coatings provide better performance. So the first part of that statement, that zirconium coatings are thin, is absolutely true. That's why zirconium is often labeled nanotechnology, because the coating that builds on your part when zirconium reacts with it is very thin, measured in a nanometer scale. So that's why we call it nanotechnology. But the good thing about the coating and the chemical reaction that takes place with zirconium is the chemical reaction is self-limiting, meaning if you leave the part in there for an adequate minimum amount of time, the chemical reaction will finish and complete with a non-porous uniform coating on your part, which provides a really good barrier and protection against corrosion and also provides excellent paint adhesion. Now let's contrast that with traditional iron phosphate and zinc phosphate coating technologies. As your part goes through the stages that have a phosphate-based technology in it, the chemical reaction will begin and a coating film will start to build on that part, and that reaction will continue to go as long as that part is exposed to the iron phosphate or the zinc phosphate. And the problem with this is once you get an adequate coating, if the part remains in the stage longer than that, it'll continue to build and you'll waste chemistry, and then worst case is it will overbuild to the point where it will actually interfere with a good adhesion of your top coat, your paint, and the part, and you'll have to reject the parts. So in this case, thicker is not better. The other problem with the phosphate-based coatings is that they're porous. So it's still, even though there's a thick coating on there, it's not a complete and uniform coating. It's a porous coating, and those pores or holes allow the opportunity for agents of corrosion like moisture and salts and other things to contact the surface of the part. So this is why you see a lot of chemical suppliers recommending that you run a sealer stage at the end of your process to put a sealer to plug up those holes in the coating, on the conversion coating. And the ironic thing is, what do you think is in those sealers that you put on your phosphate-based chemistry? Right, zirconium. And that's because it's non-porous and it's a very excellent coating for protecting the part. So what a lot of the industry has discovered at this point is, why am I wasting money on phosphate-based coatings that are not going to fully protect my part? Let's just skip that and let's put zirconium down on the surface directly and get that nice non-porous coating on there to give me good adhesion and corrosion resistance. And just looking at, traditionally, zinc phosphate has been the gold standard for corrosion resistance, with iron phosphate being the cheaper workhorse technology. And what you find now is that zirconium will blow the socks off iron phosphate in terms of performance, and it will also rival, and in some cases we've actually seen exceed, zinc phosphate performance. And you don't need to run a sealer, you don't need to heat the bath, and so you end up with a very economical solution in zirconium that actually performs very well compared to these traditional phosphate technologies. Hopefully this has been helpful in debunking the myth that thicker means better when it comes to coating performance. If you have any questions about this or any other topics related to pretreatment, feel free to contact me or one of the other members of the Solution Squad at the links below. Thanks for listening.